Hey class, it's Professor Brandon Stevenson again. So I can't say full professor. I'm not quite yet full professor. It's crazy for those that are in the academic world on how long it takes you to become full professor. Here at Weber State, it's like 12 years. So I've got a little ways to be full professor. Anyhow, this week we're talking about OSHA. OSHA is pretty cool. For those that aren't familiar with it, we're just going to be going over it from a pretty high level, and we're going to go into a couple of standards, which I think would help us quite a bit. I won't be too long-winded on it. We'll watch a couple of videos, which I think are kind of interesting. One of the reasons why we do OSHA, and then we'll talk about SP2. I was just talking with Jessica, seeing if we do SP2 across the board. I know in the associates program we do. In my 3000 class and 3760 and so forth, we haven't been doing it, but that might be something that we'll maybe have you guys do next week. So got to talk to some of the other folks and be able to get you guys login information. All right, I'm a heavy mouth breather, so I'm going to give myself a minute to breathe, and then we'll get into it. All right, so OSHA, what is OSHA? So in the OSHA, you got your mission statement. With the Occupational Safety and Health Act of 1970, Congress created the Occupational Safety and Health Administration, called OSHA, to ensure safe and healthful working conditions for workers by setting and enforcing standards and providing training, outreach, education, and assistance. So it's kind of synonymous to OSHA being a little over the top. There's a picture. Let's see if we can find it. I wasn't planning on doing it, but I think it might good. What happens when OSHA gets engaged? So here is a cowboy riding a horse, and after OSHA does their inspection, here's all the stuff that needs to be added to make sure that that cowboy riding the horse is safe. So a lot of times people think of OSHA as this little over the top, a little bit crazy organization. Look, we got headlights, safety glasses, all these stripes sitting on this horse, which we don't feel that we need. But if we think about it, these things could actually make this cowboy a lot safer. And that's kind of the purpose of OSHA, is just making you or us workers safe in whatever type of environment that we're in. So the OSHA Act covers most private sector employers and their workers, in addition to some public sector employers and workers in the 50 states and certain territories and jurisdictions under federal authority. Those jurisdictions include the Districts of Columbia, Puerto Rico, the Virgin Islands, American Samoa, Guam, Northern Mariana Islands, Wake Island, Johnston Island, and the Outer Continental Shelf Lands as defined in the Outer Continental Shelf Lands Act. So it's not just in the immediate United States, but some of those other territories and jurisdictions under the U.S. federal authority. States are able to institute their own plans of OSHA. So here is a map, and the way to get to that, I should probably show you. It's OSHA and then state plans. So if you want to see if your state plans are anything different than what the federal regulations are, you can do that. Now, state plans are OSHA-approved workplace safety and health programs operated by individual states or U.S. territories. There are currently 22 state plans covering both private sector and state and local government workers, and 7 state plans covering only state and local government workers. State plans are monitored by OSHA and must be at least as effective as OSHA in protecting workers and in preventing work-related injuries and illnesses and death. So you see all of these states. We've got some that, like in Utah, have their own state plan, but that state plan should cover everything that OSHA does from the federal level and more. So your state plans should actually be a little bit more stringent. So if you look at some of these states, you won't be surprised by what we see that Illinois having theirs. But what you can read is it covers the state local government workers only. So the private sector is still the private sector still needs to be covered by the federal laws. Now, what happens when we don't have OSHA? Here is a factory in China. So it's not too difficult to find different manufacturing or warehouse injuries. You can even find them in the states where people aren't following all of the recommendations or standards created by OSHA. So in this 45-second video, let's just see what happens to two separate employees. Let's see if we can catch it. And I had to turn off the volume because it gets a little graphic. So let's replay. We have this worker here reaching over to do something. Robot hits him. And if you watch, I'm not exactly sure what this shelf looking unit is made out of, but that robot pushes down hard enough that it bends it. So it doesn't look like it's exactly thin, but whatever that material is, there's enough force that it bends it. And if you listen to the audio, this guy is screaming the entire time. Now, in your standard US factories, there's going to be a big red button to shut everything down. I don't see any big red buttons. Not only that, I've been in quite a few of the factories for Cummins here in the United States, and where they have these types of robots moving, there's no humans at all in them. So where you got these cranes and things that are being operated automatically, there's no reason for a human to be in that area. And if a human does enter it, the robot senses you and shuts down. So you get in big trouble because you just shut down the line or whatever because you've gone where you're not supposed to do. And plus there's emergency shutoffs for everything and emergency releases. So you've got this guy that gets trapped. His buddy comes in to help. Now you may have watched over here to see what happened. The line is still moving. This thing's still going back and forth. Climbs underneath it while it's still in operation. These guys come over to help and boom, both of them get trapped. And you saw that this metal also got bent up. He doesn't look super happy. They're not screaming like this guy is. This guy's definitely in a lot more pain. But they're trapped and they're unable to move. And if you look where his head went and his neck, that could have been real bad news. Do you see his leg moving? And then eventually you'll see his hand come up and move it. So it didn't paralyze him, but it very well could have. See, there's his hand just waving on how things could have gone. Eventually shut down the line. See these stop moving around, but still have that person. Oh yeah, the spy balloon. Okay. So I thought that was a pretty interesting one just based on all the factories that I've been here in the United States with Cummins. And that wouldn't or shouldn't, obviously things that aren't supposed to happen do, but none of the factories that I've been in or toward, whenever there is a fully autonomous or robot that moves by itself, there's nobody within distance of it. So it'll lock out. And then if somebody does come in, it's going to turn off itself. So kind of interesting. So we talked about the state plans. There's going to be one in Utah. We have our state plan, which exceeds what the federal regulations are. And then what you can do is you can search for different standards within OSHA. In our industry, one of the things we talk about all the time is PPE, or personal protective equipment. So what exactly is PPE? So personal protective equipment, commonly referred to as PPE, is equipment worn to minimize exposure to hazards that cause serious workplace injuries and illnesses. These injuries and illnesses may result from contact with chemical, radiological, physical, electrical, mechanical, or other workplace hazards. Personal protective equipment may include items such as gloves, safety glasses and shoes, earplugs, or muffs, hard hats, respirators, or coveralls, vests, and full body suits. What I found, what is really interesting, going from kind of the shop environment to the mining environment, is in the mining environment, you have all of this and then some. So in the shop, you might see a guy wearing safety glasses. That's kind of up to them, even though OSHA standard is you should be wearing safety glasses all the time. You should be using hearing protection all of the time, steel-toed shoes and so forth. So all protective equipment should be safely designed and constructed and should be maintained in a clean and reliable fashion. It should fit comfortably, encouraging worker use. If the personal protective equipment does not fit properly, it can make the difference between being safely covered or dangerously exposed. When engineering, work practice, and administrative controls are not feasible or do not provide sufficient protection, employers must provide personal protective equipment to the workers and ensure its proper use. Employers are also required to train each worker required to use personal protective equipment to know when is it necessary, what kind is necessary, how to properly put it on, adjust, wear, take it off, the limitations, the proper care, maintenance, useful life, and disposal of that. So OSHA always pushes for PPE to protect you or me, the worker in the case. There is a portion here that I was looking for around payment, which is right here. So payment for PPE, that's always one of the debates of, okay, who's paying for my safety glasses? Who's paying for my steel-toed boots? Who's going to pay for my ear protection? And OSHA actually pretty clearly outlines that for everyone. Now, if you have your own business or want to start one, they have a lot of good handouts here within the OSHA website. So you search for a topic just like we did for PPE. They got this handout. We'll look at another one in a little bit. So the handout training materials, there's a poster for it. There's an hour training that you can do as well. But what I like to see is, okay, who is responsible for paying for PPE or personal protective equipment? So according to the Federal Register, this particular rule stipulates that the employer must pay for required PPE, except in the limited cases specified in the standard. So safety toe protective footwear and prescription safety glasses were excluded from the employer payment requirement in large part because these items were considered to be very personal in nature and were often worn off the job site. So if you go into this final rule a little bit deeper, if it's something that is there to keep all employees safe and isn't something that you take home with you, then your employer should take care of it. Your employer should pay for it. So if you've got a tool that is broken at your shop or your facility, a lift that isn't certified, anything of that nature, then your employer is responsible for that. But safety glasses, steel-toed boots, because that's something that you generally will wear in and out of the shop, then they don't have to because it's something that you will also use for personal. The other one that I wanted to talk about specifically was our lockout tagout. It's something we haven't done too much here at Weber State because we haven't done a whole lot of stuff that requires it. But whenever you're working with something that has hazards to it or hazardous energy, using a lockout tagout procedure is probably pretty helpful and useful. Going back to my time in the mining space, lockout tagout was everything. There's something here in the North America called MSHA. It's a type of training that you have to do to go on pretty much any of the mine sites here to make sure that you, a person in the mine site, are going to do things that's safe. And one of the things that they cover is lockout tagout. I took some pictures and I wanted to share about different types of lockout tagout. So in the shop here at Weber State, we do have this box for a lockout station. Now, you should lock out anything that you feel is unsafe. So if there's a lift that is working improperly, a welder that's arcing when it shouldn't be, anything of that, there should be a lockout. So we'll go into the details a little bit more on the lockout for it. One of the things that I see in the high voltage space is when you remove a manual service disconnect or an MSD or any type of isolation procedure for the high voltage battery, it is probably a good idea to lock that out. That way, nobody else tries to put that in or to ensure that that vehicle is safe while you are working on it. Generally, you'll see in the mining stuff, it'll be a picture of the person. Everybody has their own lockout tag. It'll have a picture of them saying, do not operate, I'm working on this. And what you are supposed to do, if you lock something out, you are the one responsible for unlocking it. So you'll see these types of carabiners all the time on the big mine stuff. So you'll have the person, their lockout tag, and their specific lock, and you are responsible for unlocking it. If you leave for lunch and don't lock your thing out, it's a huge deal for them to take that lock off without you present. Basically, general manager has to get engaged, all of this sort of stuff, and they have to do triple, quadruple checks to make sure that you're not actually present in the equipment. Because on that big mine stuff, it's as big as a house, so they don't know if you're underside it, inside it, what's going on. I feel that this should be a little more prominent in the automotive industry when we're dealing with our high voltage stuff. Make sure that you aren't in that equipment at any point, touching anything that could endanger you if somebody does re-engage the high voltage system. One thing I wanted to show is this. You see, this is a carabiner, and we'll kind of go over why that's probably not the right process to do a lockout. So whenever somebody says a lockout, it's a physical lock. There's also something called tag out, and we'll look at that as well. So we had hands-on competition here at Weber State. So every year we have a written contest for the high schoolers, and then we have a hands-on contest as well for those that essentially win the written test. So the written test, we have, I don't know, 30 plus schools that participate in it. And then the top schools will come back for a hands-on competition. And then the top 5 schools get scholarships to try to encourage the students to be able to come, give out some tools, toolboxes, and so forth. We have a particular lift where the vehicle wasn't parked on there straight. And it's kind of confusing how the actual lifts are set up. This lift box or these lift controls are right in front of a lift that actually is not the one that you're lifting. It's to another section of the shop. So to ensure that nobody accidentally used that lift, first we labeled what the lift was for. So this was for the Chevy Colorado. Outside the picture, it says what station, and then we locked it out. And to ensure that nobody accidentally did it, it was me and somebody else that locked it out. So both of us had to agree that, yes, this is safe to now operate. So we would use our key, and our key can't unlock somebody else's lock. That's another key part, is that to unlock it, it's the person that locks it to put it on. And there's that lockout station again. Here's another acceptable form of doing a lockout. If you're able to write on the lock whose the property of the lock is. So if a vehicle or piece of equipment is locked out, somebody needs to know who they need to contact. So if you look at these lockout boxes, it says it's locked out, do not remove, and property of. So you put your name, maybe a phone number if somebody needs to contact you, and then you should have that key on your person. You shouldn't leave it for somebody else because you have to be, or you should be, the physical person to remove it. So what types of things do we need to lock out? Let's talk about hazardous energy. Energy sources include electrical, mechanical, hydraulic, pneumatic, chemical, thermal, or other sources in machines and equipment that can be hazardous to workers. During the servicing and maintaining of machines and equipment, the unexpected startup or release of stored energy can result in serious injury or death to workers. And unfortunately, this does happen. That's why it's so important to understand what lockout tagout does. And one of the shops that I worked at in Salt Lake, we had a truck that dropped off the lift, and that was because our swing arm locks weren't working properly. So we had somebody from Osha that came out, inspected everything, and we had multiple locks or multiple lifts that were actually failed because of it. Multiple of our lifts, the swing arm locks. So the lock on the arms that's supposed to lock it in place were either faulty or just completely removed. Somebody actually physically removed the locks off of mine because they were sticking all the time. So like, whatever, and threw them away. They left and never put them back on. So we had to lock out a lot of our lifts. And to do that physical lock, you have to cut the power, cut the pneumatic source, or whatever it is that engages that piece of equipment to make it so you can't engage it anymore. So workers servicing or maintaining machines or equipment may be seriously injured or killed if hazardous energy is not properly controlled. So again, what is hazardous energy? It can be any of these things. We're not just talking about electrical energy. It can be thermal energy. Injuries resulting from the failure to control hazardous energy during maintenance activities can be serious or fatal. Injuries may include electrocution, burns, crushing, cutting, lacerations, amputating, or fracturing body parts, and others. Steam valve is automatically turned on by burning workers who are repairing a downstream connection in the piping. A jammed conveyor system suddenly releases, crushing a worker who is trying to clear the jam. Internal wiring on a piece of factory equipment electrically shorts, shocking workers who's repairing equipment. So these are different examples of what can happen. So what can be done to prevent this hazardous energy? So proper lockout, tagout practices and procedures safeguards workers from hazardous energy releases. OSHA's lockout, tagout fact sheet describes the practices and procedures necessary. So it's good. Again, OSHA has this little click the button, pull up the fact sheet. And actually, I just printed this off and I'm going to laminate and put it next to our lockout tagout box. And so it gives you just a very high level. How do we do these different lockout tagout procedures? Who's in charge of it? One of the things that I like about it is documenting it. So I think I have, that's the 147. That's this one here. So 147, B4I, B4. Sorry, I was reading some of the other ones. So procedures shall be developed, documented, and utilized for the control of potentially hazardous energy when employers engage in activities covered by this section. So the employer should set forth what your particular procedure is for your location. As I mentioned in mining, OSHA, or not OSHA, MSHA, standardizes that for all the mine sites. So all the different mine sites will follow the MSHA. Sorry, it's super hot in my office. MSHA is going to standardize what that procedure is, and then all the different miners are going to follow that same procedure that MSHA puts forth. So OSHA says you, the employer, should do it. Now, this is what you should do when it comes to kind of creating that procedure. So the employer need not document that required procedure for a particular machine or equipment when all the following elements exist. The machine or equipment has no potential for stored or residual energy or reaccumulation of stored energy after shutdown, which can endanger employees. So if you shut it down, what do we have to be worried about for re-engagement? The machine or equipment has a single source of energy, so can be readily identified and isolated. Going back to our lift, we had that one lock that once you're isolating that, you're not able to repower the lift and so forth. The other part that I thought was really interesting, as I mentioned, we saw that one with the carabiner. You continue down what the lockout devices should be. So lockout devices shall be substantial enough to prevent removal without the use of excessive force or unusual techniques, such as with the use of bolt cutters or other metal cutting tools. So if you're doing a proper lockout, does a carabiner suffice for that? It doesn't, according to this. It should be something that you have to use excessive force or unusual techniques. A carabiner, unclipping it, that's not an unusual thing. That's for a lockout. Now, tagout devices include, and their means of attachment shall be substantial enough to prevent inadvertent or accidental removal. Okay, carabiner can still be accidentally removed, so maybe not. Let's continue reading. Tagout device attachment means shall be of a non-reusable type. Well, there goes our carabiner. Attachable by hand, self-locking, and non-releasable with a minimum unlocking strength of no less than 50 pounds. So in our lockout tagout box, at one point in time, there were some zip ties. So no less than 50 pounds, having general design and basic characteristics of being at least equivalent to a one-piece, all-environmental tolerant nylon cable tie. So if you're doing a tagout instead of an actual lockout, You could use something like a zip tie, but that zip tie has to be strong enough to provide locking strength of 50 pounds. So if it's something that you can easily pop off with your hands and you're not the strongest guy like me, then that zip tie is probably not strong enough. If it does require a little bit more oomph than over 50 pounds worth of force, then that zip tie would work. Now, what exactly is the difference between lockout and tagout? We've been kind of using those synonymously. Now, let's talk about tagout. So we reviewed what it said for the actual lockout, and this is a really good kind of picture dictating what we had just read. So where tagout devices are used, the energy isolating device designed with the capability of being locked to the tag attachment shall be fastened at the same point at which a lock would have been attached. So you can put the tag out in place of where a lockout would go. It warns against the hazardous, so this is everything that the tag should say. Indicates that an energy isolating device cannot be controlled or removed until the operator, the person who would put it on, says it's okay to take it off, and be constructed so that exposure to water moisture will not deteriorate the tag. So all of ours are laminated, and identifies the employees or employee who attached the device. Warns against hazardous conditions if the machine or equipment is energized, and shall include the appropriate legend such as do not start, operate, do not energize. So that's all the stuff that the tag out should say. Now, what's the difference between your lockout? Lockout is physically ensuring a machine is inoperable while repairs or adjustments are made with the use of a padlock and suitable device. So that's our lockout. And tagout. Tagout is clearly communicating to workers that the equipment is being serviced with labels and tags when lockout is not a viable option. So I think that last part is pretty important of when lockout is not a viable option. So it might be something you might want to start thinking about doing, especially if you're working on hybrids or electric vehicles. Now, this isn't just to protect you. This is to protect others around you or others that might be engaged with the piece of equipment. What's kind of cool what Tesla does, and I wasn't planning on doing this, but see if I can find what Tesla does, which I think is pretty awesome. They have a way to lock out somebody from remoting into their car. So with the Tesla app on your phone, you can unlock, you can what they say, start the vehicle, which is essentially put it into ready mode. So if you've taken any of John's other classes that talk about ready mode, it's essentially being able to put the car into drive. So the car says ready, yep, I'm ready to start driving. And what Tesla has is they have this option, it's called service mode. So it locks users of the app from being able to do anything to their car. So you just click on software, you press and hold where your model is. It comes up with this little screen. You type in the word service. And it says, yep, when you're in service mode, you are limited to 7 miles per hour. Yes, I want to engage it. Come on, person, just click accept. Hey, they got a Rivian in front of them. This is interesting. And then it's in service mode. So while it's in the service mode, you've got a limited speed limit. It shows the VIN. I don't know if that person wanted to show their VIN off. Interesting. But the most important part is it prevents somebody from sitting in the service drive or whatever from turning on their phone and clicking on the climate control. If you're doing any type of service with the HVAC system, they click on climate control. Obviously, that's not going to be safe for you. So it's kind of neat that Tesla has this option. And I'm interested to see what other OEMs are doing when it comes to all of the telematics or remote work that people can do with their cars, just engaging. It's a lot more than just turning on the radio, but when you can adjust your climate control, adjust your seat, change which driver it is, that could be really unsafe for the person servicing the vehicle. anyways, so going back to our lockout tagout, you as a technician or an instructor or whatever your profession is, it might be important to start thinking about what you can do to keep yourself and those others around you safe if you are doing anything on a piece of equipment. So even as simple as, I don't know, you've taken the oil filter off a vehicle, you're doing the middle of a service or something, somebody might come up and try to start it. It might be a good idea for you to have the vehicle maybe not essentially locked out, but at least tagged out. That way they think twice before they try to turn it on and start it. So what I wanted to have everyone do for the assignment for this week, just a quick one paragraph of looking at an OSHA requirement or a OSHA standard and how something doesn't apply to it. So what I was thinking is we've got this hydraulic press YouTube channel, and maybe it'd be interesting to look at what type of safety procedures they may or may not be following. So seeing different things kind of blow up on his hydraulic list, as cool and fun it is these videos are, is there something that he's doing that is against OSHA regulation? So you can watch a couple of these videos, maybe your kids would like it, and then just look at the OSHA standard. All I did was search within the OSHA. So they have this wonderful search bar, which can say, okay, I want to learn about hydraulic. And if I can spell it correctly. So there's a lot of different options that come up. What I did is I just searched the one that talked about hydraulic press safety using machine guards. And from the videos, I'm not seeing any of the machine guards. So maybe you can just look at the video and do a search in OSHA. It doesn't have to be this particular thing, maybe something else that you like on YouTube that is kind of funny, but being able to cross-reference it from OSHA and how they're not following that. At the start of this video, I think I talked about SP2. So SP2 is something that we do here at Weber State to ensure that everybody is aligned on what our safety standards are. And SP2 even covers out your lockout tagout procedures. Oh no, I don't remember my login. But next week, what we'll do is I'll be posting something about SP2. I'm going to try to find out if you guys have login details yet or not. If you don't, I'll make sure that everybody has an ability to log in and then go through the SP2 training. We have our associate students do it, and we used to have all the bachelor students do it. As I was talking to Jessica today, doesn't seem that we've been doing that lately. So it'd be good to have everybody do that. And what we've noticed here at Weber State is there's kind of a lack of understanding of what the FM or the facility management crew does versus what we do. So they wanted to put us all through these different types of trainings and understand, they wanted to teach us what OSHA was and wanted to teach us how to use a material safety data sheet and stuff like that. And like we do all of that through SP2, and they didn't know what SP2 was. So we've been actually teaching our facilities management about SP2, and they're really interested and like it. And they might actually make it a college-wide training for everybody to take, because it covers spills and slip hazards and everything, which is really good, which is why we have our associate students do it and why we used to have our bachelor students do it, which is why we'll have you get back into that. So I'll be posting this video. Hope everybody likes it. If you have any questions about this week's work, I'll clearly outline that, yes, you just need to put a paragraph together about something like this hydraulic press video against what OSHA says about what he's doing and what he could be doing that might be a little bit safer. All right, everyone. It's always great being able to put this content together, and hope everyone's having a great week. We'll talk to you later.